Thanks for joining us on the Cultured Meat and Future Food Show. We're hosting Tom Ben Arye on this episode. I first met Tom in the Netherlands in early 2018, and we recently met at the International Conference for Cultured Beef in Maastricht. Before we get started, I wanted to mention some of the great upcoming future food events kicking off the new year. Cellular Agriculture UK is hosting an event in London on Tuesday, February 26th. Learn more about this free event and sign up at www.cellag.uk. We're thrilled to announce our partnership with the Industrializing Cell-Based Meat Summit, the Cell Ag-focused forum that will address the current commercialization and regulatory challenges cell-based meat companies and researchers are facing. The event is taking place in San Francisco on February 5th to the 7th. Learn more and sign up at www.industrializingcellbasedmeats.com. Use the coupon code CMS10 for a special discount. Live Cells versus Livestock Innovation in Cellular Agriculture is taking place at Santa Clara University on January 24th. Panelists include Liz Specht from the Good Food Institute, Brian Spears of New Age Meats, and Sam Shahrokhi of Mission Barns. And on January 22nd, we're hosting a biotech workshop about rigor and reproducibility at Bonneville Labs. Learn more and RSVP to these events at www.futurefoodshow.com/events. And finally, the Alternative Protein Show is taking place in San Francisco on Tuesday, January 15th through Thursday, January 17th. Learn more about the show and register at www.newprotein.org. Tom is an Israeli Ph.D. candidate developing clean meat in the Levenberg lab at the Technion, Israel Institute of Technology. He finished his B.S. in molecular biochemistry in the Technion with great honors and his M.S. in the Levenberg lab. During his Ph.D., he initiated a clean meat project, from which the startup company Aleph-Farms emerged. Tom is a co-founder of the Modern Agriculture Foundation, a past board member and the scientific advisor of the organization. Tom, I'd like to welcome you to the Cultured Meat and Future Food Show.
Hi, Alex. Nice to meet you.
Tom, please tell us a little bit about why and when you became a clean meat researcher and how you first started working on your research and what you're working on at the moment.
Yeah, I decided to work on clean meat about 10 years ago. I was an animal rights activist for many years. I volunteered giving lectures, organizing demos, but it didn't seem enough. Even though we saved millions of animals that way, it didn't solve the problem. So me and a couple of other effective altruism activists, we sat down and thought of possible solution to the meat industry, and clean meat came up. So I went to the university, and after finishing my bachelor's degree, I joined the stem cells and tissue engineering lab that already knew how to produce muscle tissues. Our project is basically to replace the human cells with bovine cells and replace the expensive medical biomaterials with inexpensive food-grade materials to produce clean meat.
Great. And when it comes to academic research versus private companies funding research in the field of cellular agriculture, how important do you think it is for universities to be involved?
Yeah, so I think both academic research and industry are great ways to advance cellular agriculture. It really depends on your personality, whether you fit better, and you can always switch between the two. It's not like a Catholic marriage. Overall, in order to advance clean meat, we need both. The advantages of academic research is that they are usually more open for sharing information, something that I sadly don't see much in the field of clean meat. You can't really find much biological research articles on clean meat.
And going back to what you were saying earlier about how you got started, are you currently on a completely plant-based diet yourself, personally?
Yeah, I am. I'm a vegetarian since I was 4, and when I was 15, I turned vegan. When you realize what happens in the industry, it's hard not to. There is just no other option, in my opinion. Maybe in the future we will have something.
Right. In your research, have you tested or tasted or tried clean meat?
Yeah, I don't think it's a very good decision that I will be the one who will taste it because I don't really remember the taste of meat. So maybe other people will like if it will be it will really be a waste to let someone like me, which didn't eat meat for like 25 years to try it because okay, I will say it's tasty but I don't know if it will be similar to meat from animals. So I didn't taste it. However, I will surely taste it when it will not have any animal products in it. Currently, we still use some animal products, but when it will have no animal products in it, I will surely try it. Because why not?
Great. And so the animal products that you're referring to, is that primarily in the serum?
Yeah, so in the research itself, we use some serum because it's just simpler and easy. However, in the future, when we will get to a mass production, we will surely not have any serum in it because it's not even food grade. So obviously, we will not have it. It's just part of the research and development of the R&D process.
Right. And so the serum that you're using is a fetal bovine serum.
Yeah.
Do you have any animal-free serums that you're using for the research phases?
Yeah, we do. However, I think that we do have serum-free media. However, I think that for the research, it's not that important to use the serum-free media because it's just more expensive currently. I think that in the future, when we will get to the mass production, it will surely be something that we will need to do. However, in the research phase, I don't think it's that critical not to have any animal products.
Right. I've heard that with fetal bovine serum, I guess any type of serum, the consistency in results is not optimized or as desirable as you would like it to be. What kind of consistency do you have when working with the different serums?
Yeah, this is a great point. Basically, I will jump into this small point, a small anecdote. When you work with serum is not just a problem in the cellular agriculture. Serum is a problem for the entire scientific community because it has huge variability and it's not very defined. So I believe that solutions to the serum problem will happen even without us. So I don't think we should invest much work into trying to find different serum-free media at the time. However, we will need to make something like this at the end for the clean meat. Your question about, now I forgot the question about the serum-free media. Oh, you asked about the variability. So we are just using the same batch for all of our experiments to lower our variability. However, at the end, this batch will end and we will need to have a new batch. And then the results might be totally different. As long as you work in the low scale, in a small scale production, it's not that difficult to have just the same batch of serum for all of your experiments. You just use this, you have enough because you don't use that much. But after you will try to make tons of this clean meat, you will surely need to remove the serum because it will have huge variability and also it's not even a food grade or meant for a clean meat.
Are there any current products that are being made in a large scale? Of course, not food products, but products that are made at a large scale that require FBS in the biotech world? Any products at all?
I don't know about these kind of products. I know that in the industry, they try to work with serum-free media, but maybe there are that I'm not from the industry, so that's something that I would really recommend to ask someone from there. Maybe for growing killer cells or something like that, or CHO cells, maybe there is some use of serum. I really don't know.
Okay, so let's talk a little bit about 3D printing. So how could 3D printing be part of clean meat production? And are we already seeing any type of 3D printing techniques getting involved?
Yeah, in the field of tissue engineering, we can use 3D printers to print cells on the micron level, which is really cool because you can really design your tissue that way. However, if you want to print an entire burger with a micron scale resolution in a cost-effective manner, you need extremely high processivity, which is currently unavailable. At least yet. It can be good enough for academic research, but not for mass production of clean meat, at the moment at least.
And when we're talking about 3D printing, what exactly is it that we're printing and what kind of printing material is being used?
Mm-hmm. You have several options. First of all, you have sacrificial molds or scaffolds that you can create using 3D printers just to have the basic construct. You can also bioprint biomaterials, which is a really cool way to print like more complex scaffolds that are good for cells. Basically, you want to make an environment where cells can feel at home, so they will act the same way as they do in the body. If you can bioprint a scaffold like this, that could be something really useful for the cells, and you can design where the exact structure of the scaffold that way. Also, another thing that you can also print is the cells themselves. If you want to align cells, that's a very good way to do it. If you want to have cell interactions, you can align them one next to the other, and that way you can, for example, create tubes, myotubes, which are aligned to one another. That's something that can be really interesting, and to see how it affects them. It's basically a great tool in order to affect the interaction between the cells, which is something that is important for the R&D and might be really useful for the mass production. However, it's not there yet, at least for the mass production.
Is what you're related to vascularization at all?
Yeah, totally. If you want to do vascularization, if the cells are already aligned, that's something that can be really useful. And the vascularization is also a really important part of the clean meat production. Vascularization is something that can be a crucial part of the clean meat product.
Cool. When we're talking about clean meat, one of the most popular topics right now is IP, or intellectual property. What's your opinion on open collaboration in the field? And do you think that cellular agriculture will be more of an open access field in the future, or closed off by the startup companies and investors that are putting money into the field?
Yeah, I think that's a very crucial point. Currently, I don't see enough collaborations, and it's a problem because clean meat is a huge project. I don't believe one company alone will be able to solve the problem, and only through joint effort we might be able to succeed in disrupting the meat industry. The thing is, investors, as you said, they don't like the collaborations because they are mainly competition oriented and want to keep their intellectual property. We basically need to make them understand that if they go this path, they will not get anything. And through collaboration, they will get their return on investment. It's not that difficult because the meat market is huge, so there is enough for everyone to share. In the last Clean Meat Conference, Sasha Mendy, which is a lawyer and a patent agent, he gave a really good talk about how companies can collaborate and still keep their interest. He gave two scenarios. The first one is a patent pool, where everyone in the pool can use other patents. In order to join the pool, you should pay a regular fee, and a good example for that is creating the Bluetooth. Bluetooth was done using a patent pool. Another way to collaborate is a patent pledge. It basically means that we will not enforce our patents against those who will not enforce their patents back at us. These are two ways that companies can collaborate. And I think that's a really good point, because if we will not have all of these collaborations, we will basically get nothing at the end, and no one will get anything.
Interesting. And that's a really good example, because I know like Bluetooth or Z-Wave Alliance really has a group working together to make sure that their tech is open to these different companies. So that really interesting way to look at how that could look for clean meat.
Yeah. What I wanted to say is that if you look at the meat market, if one company can start in Israel and another one in the US, until they will start the competition, it's just such a huge market. Talking about competition is just ridiculous. It's like $1 trillion market, and there is enough for everyone. If you invest in this field, you will get your return on investment, even if there are collaboration between the groups.
Yeah, definitely, especially when we're looking at a lot of industry sizes and few of them have trillion instead of billion. So food is definitely a big one, yeah. Cool, so we have been doing research on clean meat for quite some time, and we haven't seen the efforts of going into large-scale production. So what are some scientific milestones that need to be achieved before we start producing clean meat at a large scale?
Yeah, so that's a good point. We are always talking about it, and there is hardly, we always ask, where can I taste it? So there were some tastings, but in order to make something that will actually come into the market, there are actually some milestones that we do need to get. First of all, we need to develop the basic tissue and optimize it to resemble meat taste and texture. Research on muscle cells is quite common. However, tissue engineering of adipose cells is still lacking. Adipose cells is fat cell. Another milestone is the blood. Two possibilities for that is to wait for successful blood generation for human health and then just copying it to bovine, or add molecules that resemble the taste of blood, like Kim from the Impossible Foods. The major problem is still the price. We try to apply, because we are trying to apply techniques from tissue engineering to food product. In tissue engineering, optimizing for price is rarely done, and it's sort of a heresy to even suggest that. For example, when I started the project, I wanted to replace one material for another, like call it material A with material B. So material A was really expensive, and I tried to replace it with material B, which is food grade. So I asked someone, I wanted to do it, and someone told me I shouldn't do it because they tested it and saw that material A. So I asked how much is it better, and I was answered that material A gave a result of 80 and material B gave a result of 70. And I said, that's it? Just 80 and 70? That's nothing. That's like great news, because material A cost 1,000 more than material B. Even if material A was 1,000,000 times better, it's still irrelevant because it's just too expensive. So if the changes are that small, of course we need to change it. Basically, it's a state of mind that is not really common in the tissue engineering trying to optimize for something like price. Regarding price, there are not just bad news, there is also some good news. We don't really need to have the harsh regulatory requirements of the medical field, and we also don't need to have all of those expensive purification procedures. If you buy now a molecule that was generated in yeast, from now on, we don't really need to purify the molecule from the yeast. We can theoretically just put the yeast extract in the media, and then we'll have the molecules that we want. And that way, we can even add in some nutrients as well. So that's something that can really lower the prices of the media, which is the biggest portion of the price. Doing something like that will require media companies to develop new processes for low-grade media production systems. So that's something that I think will be really interesting.
Interesting. So I guess that what I'm thinking of is an example in the tech world would be processing power. Right? So I was speaking to somebody who was a processor engineer at Intel, and I was talking to him and saying, oh, it must be so exciting when you guys are working on the next generation processor. You kind of get a glimpse into the future because you can see how computers are getting so much faster. And he looked to me and he pretty much said, well, actually it doesn't really work like that for us, because although the public sees these huge advancements, twice the speed or whatever it may be, every week we produce a processor that's faster, but it's just slightly faster. So for us, it's all these incremental changes. And it seems to me like the research that's going on to lower the price might be in a similar facet, that it'll be incremental changes and optimizations. Would you say that's a good analogy?
I totally agree. Yeah, it's basically every time you do some change, it can lower the price of this or of that, and over time they just accumulate in order to lower the price. I do hope that we will be managed to get to comparable prices to meat from animals.
So let's shift gears a little bit, because there's this big search for alternative proteins. And lately, we've started seeing a lot more investment and people start working on different types of insect proteins, either cricket proteins or mealworms or different types of insects that are high in protein. Would you say that proteins from insects could also be an alternative in the future? And actually, on top of that note, from kind of like a animal welfare standpoint, what are your thoughts on that as well?
There are not many things that can make people in the Western world lose their appetite, like thinking of insects.
Yeah.
So I'm not sure if that's like the way to go for the Western world. Also, as you said, from the animal's perspective, it could be that insects are sentient. We don't really know. There is not much data on the matter. So it might be that insect meat will cause greater pain and suffering to animal-based meat. I would stay away from these gray areas and stick with organisms that do not have a nervous system, like plants or cells. And in my opinion, it's better. Oh, just eat lentils. Like, what's wrong with that?
Yeah.
Like, you are willing to go this far to eat like cockroaches when you just have lentils? No, I would stick with the lentils for now.
Right. If someone is trying to get into the clean meat space, do you have any suggestions for which academic path they're going, or any specific universities that are heavily involved in clean meat research?
So if someone wants to help advance clean meat, I recommend studying biotechnology and food engineering. It can help open many doors for you, and also not only in the clean meat sector, but also for other animal-free products. Basically, if we want to create food products, we need food engineers. It just makes sense. Recently, there is a burst of funding for food tech in Israel. It's a university in the Technion where I work in. If you are interested in investing in clean meat, I highly encourage you to send an email to the Good Food Institute. They are extremely helpful, nice, professional, and will help you find the best route to advance clean meat and plant-based meat around your areas. Also, it's something very important to find something that you will be good at. Or you can go to study biotechnology and food engineering, but you can also study to be a lawyer. Then find how to help with the regulatory problems or the connection between the companies. Basically, each person will have its own path that will be optimal for him to be as effective as possible for the research.
When we're talking about clean meat, have you heard of anybody focusing on optimizing for flavor or taste from a culinary perspective?
I did not. And I think that's very crucial. And that's something that you don't really hear about. You talk about people who do try to add muscle or try to add fat that should affect the taste. But I rarely hear people talk about, I see people working on mass productions of cells. And I see people work on the tissue engineering, on the food engineering, on making it into a food product. I hardly hear anything about it. Some people say that we should make the basic tissue and only after that try to develop it to optimize the taste and the texture and all of that. Optimizing for taste should be done from point 1, from point 0. Because for me, I know how to assess whether you have more myotubes, if you have more expression of specific protein that are expressed in muscle. However, for me, in order to understand if an experiment is good or not, if results are better or not, in order to do the optimization, I need to have the measurements of the flavor, of the taste, because seeing that you have more vascularization or more myotube formation doesn't mean that necessarily it will be a better taste. For that, we have to have a standardized test done for clean meat that will really help understand whether a specific sample is better or not. There are tools like this for meat. There is a food scan for meat, which takes samples of 50 grams and assess the quality of the meat. The thing is that when you work on a clean meat, you cannot have a 50 gram sample, just put it in the machine because you don't have 50 grams is huge for clean meat. If we can miniaturize a machine like that for something like 50 milligrams, that's something that can really boost the clean meat research. This thing is not something very complicated because the machine that requires 50 grams of meat, it doesn't really require 50 grams of meat. That's something that they just made because why not? Animal-based meat industry, 50 grams is nothing. Just take 50 grams and you put it. If you want to use it to apply it for clean meat, you need something which will be able to analyze something much smaller. And it's not something very complicated from the terms of the technology because this machine basically works on light scattering. So you just take random spots on those 50 grams of meat and assess the light scattering, and according to that, tells you the quality of the meat. If we can just make a machine similar to that will just take random places on that 50 milligram samples, that's something that can really boost all of the clean meat companies and telling them if a change that they did is better or not. Because checking if there is more myotube formation or more vascularization, that doesn't necessarily mean that you optimized it for a better clean meat product.
Interesting. I was speaking with a food scientist and chef. I asked him about potentially using clean meat technologies to combine different types of animal, chicken mixed with beef or tuna or whatever it may be. What are your thoughts on this, potentially from a culinary perspective?
Yeah, again, I'm not the best person to ask about it because I don't know the taste not of chicken, not of cow, and not of sheep. However, I did hear that people really like the fat from sheep and maybe the taste of meat from other animals. So the fact that you can really design your product on the molecular level is something really exciting. Not only you can combine different animals in the same product and the muscle from different animals, you can also fine-tune the molecules inside those cells cells by feeding the cells with different molecules. For example, if you can feed them with specific amino acids or a specific, so if you can feed them with specific fatty acids, you can alter the fatty acid composition of the final product, which is something which is rather hard to do when you're trying to feed an entire animal, to change the specific molecules inside their muscle. And I think the combination of different animals is something that can be really exciting, because basically you are making here a new food sector that wasn't there, or at least a new food products that couldn't be made before. That's something that can make people actually pay more for their product, because it's something very unique.
Right. I'm actually very excited about designer meats and clean meats. The chef that I had spoke to, although, his first response was, why would you want to? But I think this is really exciting for at least what we might be able to see. Tom, what can we expect to see from you specifically in the near future?
I'm finishing my PhD soon, so hopefully all of my results will be published by then. After that, I want to channel researchers, students, and funding into plant-based and clean meat research. That's basically my goal after I finish my PhD. And I think that's something really exciting, because in Israel, they started to have lots of funding for the field. So basically, if we won't channel the funding to clean meat, it will basically be used to create new yogurts and things like that. And I think that will be a really shame, because we can really make a change if we will help channel the resources and researchers and students to clean meat and plant-based meat.
You can get in touch with Tom on LinkedIn. Tom, do you have any last insights for our listeners today?
Yeah, the solution to the largest problem in the world, the meat industry, is very simple. Just create better product. People don't hate the animals. They don't want to destroy nature. They just don't really care. If we can make better products, people will just buy them.
Tom, thank you so much for being with us today and sharing your story on the Cultured Meat and Future Food podcast.
Thank you, Alex.
This is your host, Alex, and we look forward to being with you on our next episode.
Thanks for being a listener. Since we started the show, we've definitely learned a lot about cell-based meat, but also a lot about podcasting. We'd love to get your feedback, whether you have comments on the questions, the ads, audio quality, whatever it may be. Submit your feedback to futurefoodshow.com. Special thanks to all of our guests on the show: Julian Zvorskov for making the intro tune, Anita Brolux and Florian Schmidt for drafting the questions, Adrian Mediadipura and Cyrus Manuran for editing, Yuri Kleben for outreach, Nick Talrea for legal counsel. And most importantly, thank you for listening and spreading the word about cell-based meat and future food technologies.